An object from outside our solar system just flew past the sun. And it may be older than the sun itself. Not just a little older, possibly billions of years older. Think about that for a second. A frozen object formed around another star, drifting alone through the galaxy for unimaginable lengths of time, and then, by pure chance, passing close enough for our telescopes to study it. Scientists pointed the James Webb Space Telescope at it. And what came back changed how we think about objects from other star systems. This is not science fiction. This is not internet hype. This is confirmed science. And honestly, it is one of the strangest verified space stories of the last year. Stay with me for the next few minutes because by the end of this, you'll understand why scientists are treating this object less like an ordinary comet and more like a time capsule from another solar system. Let's start with the basics in simple terms. Our solar system has one sun, 8 planets, moons, asteroids, comets, and countless smaller objects. What all of them have in common is this: they belong here. Why? Because they are bound to the sun by gravity. They move in repeating paths, they orbit, they come back. They are part of the sun's family. But every once in a while, something appears that does not belong here at all. It does not orbit the sun. It does not stay. It does not return. It enters our cosmic neighborhood once and then leaves forever. These rare visitors are called interstellar objects. And here's the incredible part: in all of recorded human history, we have only confirmed 3 of them. Just 3. The first appeared in 2017. It was strange, elongated, and mysterious enough to spark years of debate. The second arrived in 2019. That one behaved more like a traditional comet, with visible activity and a tail. But both of them had the same problem. By the time the world's best telescopes were fully focused on them, they were already fading away. Scientists got data, yes. But not enough. Too many questions were left unanswered. So astronomers were waiting for a third opportunity. A better one. A larger object. A brighter one. An active one. And most importantly, one detected early enough for the world to prepare. Then it happened on July 1, 2025, telescopes in Rio Hurtado, Chile detected a faint, fast-moving point of light crossing the sky. At first glance, it could have looked like just another moving object. But when astronomers calculated its path, they realized almost immediately that this was different. It was moving far too fast to be permanently captured by the sun's gravity. In plain language, this object was not from here. It was not staying. It was only passing through. Within days, the confirmation came. Humanity had detected the third confirmed interstellar object ever observed. It was named 3I Atlas. The 3I marked it as the third interstellar object ever confirmed, and Atlas honored the survey system that first detected it. But this is where the story stops being merely interesting and starts becoming extraordinary. 3I Atlas was not just another interstellar visitor. It was more extreme than the 2 that came before it. Its trajectory was the most sharply hyperbolic ever measured for an interstellar object. That matters because the shape of an object's path tells you whether it belongs to the sun or is merely passing by. A gentle repeating curve means the sun has it gravitationally bound. A steep hyperbolic escape path means the opposite. And 3I Atlas had the most extreme path yet. Its speed was staggering, over 200,000 kilometers per hour when it was first discovered, and it accelerated even more as it fell inward toward the sun. But the real shock came next. Based on its motion relative to the average motion of stars in our region of the galaxy, scientists estimated that this object could be somewhere between 3 billion and 11 billion years old. For comparison, our sun and solar system are about 4.6 billion years old. Which means this is entirely possible. This object may be older than the sun. Take a moment and really let that sink in. This comet may have formed around a star system that existed before our own sun was even born. The star it formed around may not even exist anymore. And for billions of years, this object may have drifted silently through interstellar space, frozen, dark, and untouched, until it finally crossed paths with us. If that doesn't stop you for a second, I don't know what will. there was another major reason this object became such a big deal. Unlike the first interstellar object, which appeared mostly inactive, 3I Atlas turned out to be an active comet. As it approached the sun, heat caused frozen material on its surface to turn directly into gas. That gas streamed away, forming a glowing cloud called a coma, along with a faint tail. And for scientists, that is a gold mine. Because when a comet becomes active, it releases its chemistry into space where telescopes can actually detect it. A silent rock keeps its secrets hidden. An active comet gives them away. That meant astronomers had a rare opportunity, not just to see an interstellar object, but to analyze what it was actually made of. And this time, they had something else they didn't really have before. Time. Because 3I Atlas was detected early enough, observatories around the world had months of warning. They could plan. They could coordinate. They could schedule the most powerful instruments on Earth and in space. And that is where the James Webb Space Telescope enters the story. The James Webb Space Telescope, or JWST, is the most powerful space telescope humanity has ever built. It does not simply look at light the way our eyes do. It sees in infrared, which allows it to detect heat signatures and chemical fingerprints invisible to ordinary telescopes. That makes it perfect for studying comets. But there was a challenge. Webb was not originally designed for small, fast-moving solar system targets like this one. Tracking something moving as quickly as 3I Atlas pushed the telescope close to its limits. Even so, engineers and astronomers managed to lock onto it. In August 2025, Webb captured its first detailed spectrum. Then, after the comet passed the sun and began heading back outward, Webb observed it again in December 2025, using a different infrared instrument to get an even more detailed chemical readout. And what came back surprised scientists. The chemistry of 3I Atlas did not look like the typical chemistry of comets formed in our own solar system. For one thing, it showed an unusually high amount of carbon dioxide compared to water vapor. That mattered because comets in our solar system tend to follow more familiar patterns. This one did not. That was the first hint that it may have formed in a chemically different environment around another star. But then came the even bigger discovery. Webb detected a clear signature of methane gas. And this was historic. It was the first direct detection of methane from an interstellar object. Along with methane, Webb also detected water vapor, carbon dioxide, and something even more unexpected. Nickel. A metal signature appearing in the escaping gas of a comet is highly unusual. And it told scientists that the raw materials built into this object were both ancient and chemically intriguing. This was not just a random icy body. It was a chemical message from another planetary system. To understand why methane mattered so much, you need to know one thing. Methane is fragile. Over billions of years in interstellar space, cosmic radiation can damage or strip away lightweight molecules, especially near the surface of an object. So scientists did not necessarily expect strong methane to still be present in something this old. And yet Webb found it. That forced researchers to ask a new question. Where was that methane coming from? The leading explanation is that the outer layers of the comet may have lost much of their original methane long ago after eons of exposure to cosmic radiation. But deeper inside the object, beneath the surface, untouched material may have remained preserved. Then, as the sun heated the comet and stripped away its outer layers, that deeper material began to escape, and Webb was able to detect it. In other words, Webb may not have been looking only at the surface. It may have been reading material from inside the comet that had remained sealed and protected for billions of years. Material that may have been frozen in place since before our solar system even existed. That is an astonishing thought. Humanity pointed a telescope at a fast-moving speck of light and managed to read the chemical ingredients of another solar system. Not in theory, not from imagination, but directly. Because 3I Atlas was large, unusual, and interstellar, some parts of the internet quickly started making wild claims. Maybe it was artificial. Maybe it wasn't natural. Maybe it was something built. But science does not work by speculation. It works by testing. So researchers checked. Radio telescopes were used to search for technosignatures, any sign of artificial radio signals that might suggest the object was something other than a natural comet. The result was clear. Nothing artificial was detected. No signal. No evidence of engineering. No sign that this was anything other than a natural object. And when all the evidence is viewed together, its chemistry, its coma, its outgassing, its dust, its radio silence, the conclusion is straightforward. 3I Atlas is a natural interstellar comet. And honestly, the verified truth is already more incredible than the rumors. It does not need embellishment, so why should anyone outside astronomy care about this? Because every interstellar object we study gives us something unbelievably rare. A real sample of material formed somewhere else entirely. Not just a distant star. Not just a faint signal from far away. But actual matter from another star system, passing close enough for us to analyze directly. That means interstellar objects offer a chance to study how planetary systems beyond our own are built. They give us clues about chemistry, formation, and the diversity of material in the galaxy. And there is a second big implication. For years, scientists debated whether interstellar visitors like this were incredibly rare, or whether they were actually common but simply too difficult for us to detect. Now we've confirmed 3 of them in less than a decade. That strongly suggests the galaxy may be full of wandering debris from other star systems, and we are only just beginning to notice it. As better survey telescopes come online, astronomers expect the discovery rate of interstellar objects to increase. Which means 3I Atlas may not be a once-in-a-lifetime event. It may be the beginning of a whole new era of discovery, so here is the simplest way to say it. In 2025, a fast-moving object entered our solar system and was quickly confirmed to be the 3rd interstellar object ever detected. It may be between 3 and 11 billion years old, meaning it could be older than the Sun itself. As it passed near the Sun, it became active, releasing gas and dust that allowed scientists to study its chemistry in detail. James Webb detected unusually high carbon dioxide, the first direct methane detection from an interstellar object, water vapor, and even a nickel signature. All of it points to one extraordinary conclusion. This was a genuine, ancient, natural piece of another solar system, drifting through our own for one brief moment before disappearing back into deep space. And perhaps the most incredible part of all is this. After billions of years of silent travel through the galaxy, it passed by us during the tiny window of human history when we had the technology to understand what it was.